grade 9s. Today we are going to tackle 9.2, which is all about graphing inequalities on a number line. Now, last class, we would have done an activity on Desmos or Amplify that talks about what number lines will look like, or the graph of a number line will look like for each inequality. Today, we're just going to formalize what we've learned and kind of start practicing along with it. So we're going to start with basic inequalities, where we are going to start graphing. So taking a look, here are the instructions. Instruction number 1, you won't always be given a number line, so we will have to draw it. So we will start by drawing something that looks like this. Pretty easy, no big deal. Now, depending on the inequality we're given, we are going to put the number in that inequality in the middle. So if I have something like x is greater than 7, I'm going to go ahead and put the number 7 in the middle. The next thing I'm going to do is in a number line, we typically have more than one number present. So we're going to put a number evenly spaced on either side. Now we could put more than one number. We could put 2 or 3. But I want to make sure they're evenly spaced. So on the left, I'm going to put 6. On the right, I'm going to put 8. That's going to be step 1, where we create the number line that we need. Again, that number line will be based on the number that we're taking a look at. Step 2 is that we are going to draw the endpoint. Now remember, in the activity that we learned, there's 2 types of endpoints. There's an open circle. And an open circle is when the value in the inequality is not included. So we're going to use an open circle when we have a less than symbol or when we have a greater than symbol. The other type of endpoint is a closed circle or a filled in circle. And we use this type of endpoint when the inequality does include the value. So pretty much if there is an or equal to portion in my inequality. So if I have a less than or equal to, or greater than or equal to, if there's that or equal to portion, we will have a filled in circle. And truly we just mean an open circle or a closed circle. And that circle is not big. It's pretty much the size of the point. You just need to make sure that that circle is obviously opened or obviously closed. So if I was going back to this example here, I said x is greater than 7. I would use an open circle. And I want to make sure it's obviously open. The last step is to draw an arrow in the correct direction. So what I need to do is I either need to do this or I need to do that. Now, when we take a look at the inequality, we could just tell by saying, okay, our number is bigger than 7. What's a possible number bigger than 7? 8. Since 8 is a possibility, I know my arrow is going to have to go in the direction that includes the value 8. Now, this is a really great way to make sure that we are on track and getting our arrow in the right direction. However, there's also another sort of thing that works. Now, this only works if our inequality is written in standard form. And just a reminder, standard form will have our variable, then our inequality, then our number. And that order is what standard form is about. It's not necessarily incorrect to say things in flipped form. It's not proper notation. It's not perfectly communicated. But if it's in standard form, what we'll notice is that the arrow is going to point in the direction of the inequality. So if we go up here, we've got an inequality in standard form. And if I take a look at that inequality symbol, I could pretend almost that it looks like an arrow. And I'll notice that the arrow of my inequality will match my arrow on my number line in terms of directionality. But that is only if the inequality is written in standard form. If I had this, I'll note, which is the exact same thing, it's just written backwards, right? Because if you flip the placement of my inequality, my sign has to flip as well. I'll notice it now doesn't match. But that's pretty easy to fix. We can just write it in standard form first, and then we can verify that it matches. Okay, those are the instructions. That's what we're going to do. There's 6 inequalities here. I'm going to do the first couple with you, and then I'm going to ask you to try the next ones on your own. Okay, so first of all, I am going to draw my number line. The number involved in this inequality is 15, so I'm going to put 15 in the middle, and then I'm going to choose a number to include on each side that's evenly spaced. So I'm going to choose, let's say, 14, and I'm going to choose 16. Does it have to be one bigger or one smaller? No, as long as it's evenly spaced. So I could have technically done 13 and 17. I could have done 10 and 20, as long as they're equidistant apart. Now that I've drawn my number line, step 2 takes a look at my inequality. And I have an inequality that has an or equal to portion, which means I'm going to draw a closed circle on the number 15. Last but not least, I have to talk about the arrow of my inequality, what direction it's going to go in. I know it says that x, my number, has to be bigger than or equal to 15. A number that is bigger than or equal to 15 could be 16. So I know my arrow has to travel in the direction where 16 is part of that solution. Now, the reason that we put arrows here is because technically our number line keeps going and where our solutions are found continues. So even though on the number line I stop at the number 16, technically the number 22 is still a solution. If I were to extend that arrow, that's what I would get. Now, I'm also noticing that this inequality is written in standard form, and so the direction of the inequality will match the direction of my arrow. Okay, I'll do one more with you, and then I'll get you to try the next ones on your own. So, number line, the number 2. I'm going to put a number on either side, about evenly spaced. I'm going to put 0 and 4. I could have put 1 and 3, as long as they're evenly spaced. I'm going to make my endpoint. Notice my inequality does not have an or equal to portion, so it's going to be an open circle. I notice my inequality says that my number has to be less than 2. Well, 0 is a number less than 2, so that arrow has to be traveling in that direction. I can confirm, because my inequality is written in standard form, that inequality symbol will match the direction of my arrow. Okay, can you pause the video and try the next 2 on your own? And welcome back. Okay, going to the next ones. I've got a is less than or equal to 98. So I've got 98, I've got 99, I've got 97. I am going to have a closed circle because there is an or equal to portion. You might notice that I tend to draw my arrows and my circles slightly above the number line. Not because that's what you're supposed to do. I would love to have it on the number line. I just find if you're drawing with a pencil on something that's already black, it's really, really hard to see. So I tend to do it a little bit above so it's obvious what your answer is when you're writing in pencil on an assessment. Okay, a number that is less than or equal to 98 is 97, but again, the arrow, since this is in standard form, will match the direction of my inequality. The next one here, I've got 3.7 as my number, and I'm going to write 3.8 and 3.6. My circle will be open because there is no or equal to portion on my inequality. It is written in standard form, but if I'm looking for a number bigger than 3.7, I need to be traveling towards that 3.8. Okay, the last 2. Now, the last 2 are not written in standard form. I like to start by writing them in standard form first. So I'm flipping the order of the inequality, which makes me flip the direction of the sign. I like doing this because for me, I find it's easier to graph the inequality from standard form. It's easier for me to check. I tend to prefer to write numbers or like figure out what numbers kind of fit in that position from standard form. Is it mandatory to do? No. But if you are taking a look at what direction that arrow goes in based on the directionality of the sign, it has to be in standard form. So here I have b is less than 12. I have an open circle because there's no or equal to portion. I'm looking for a number that's less than 12, so I'm using my arrow to go in the direction towards the 11. Last but not least, this one is also not in standard form. Ay, ay, ay. So I'm changing the order of my values and I'm flipping the directionality of my sign. I still have that 1/2. And I can go ahead and say a half is between 0 and 1. No big deal. I will have a closed circle on my half value. And my arrow will extend to the left because I'm matching the directionality of standard form. Or I'm thinking what numbers could be smaller than a half. And 0 is smaller than a half. Okay. The next ones we are going to go and we're going to write the inequality that represents the graph provided. So as we take a look at this, we get to choose any variable we want. I'm going to choose x for the first one because that's usually people's go-to. I'm going to take a look at the number where the dot is. So this is a -4 in this case. Then I am going to look at the directionality of the arrow. The arrow is pointing to the left or smaller than -4. And since I'm writing my inequality in standard form anyways, I will notice that my arrow will match my inequality's direction. Last but not least, I look at the type of circle I have. I have an open circle, which means I will not have an or equal to portion at the bottom. I could do the same thing for the next example. I'm going to start with a variable. Any variable you want. I'm going to choose a. Why? I have no idea. Just because. I'm going to use the number. The number where the dot is on is the number 1. I'm going to then look at my arrow. Since I'm writing this in standard form, I'm having this arrow kind of pointing to the right. So my inequality will be a greater than. Also, I can confirm because all of the numbers 2, 3, 4, 5, 6, etc. are greater than 1. And then I look at my dot. It is a closed circle, which means I will have an or equal to portion at the bottom. All right, give the last 2 examples a go, and then come back for some more. Okay, welcome back. I'm going to use B. I've got the number -3. I have my directionality of my inequality being a less than symbol. And the dot is closed, so it will be an or equal to sign. And then the last one, I will use C. We have -5. My directionality of my inequality will match my arrowhead if I'm writing it in standard form. And I have an open circle, so that is it. So those are our basic inequalities, where we only have one inequality involved. We can write it as, or we could represent it on a number line, or we can do that vice versa. We could take the number line and then represent the inequality. What we're going to do next is compound inequalities. Now, compound inequalities are simply inequalities that involve or combine 2 simple ones together. And there's 2 different ways that we combine inequalities. We can combine inequalities using an AND statement, or we can combine inequalities using an OR statement. We're going to talk about what both of those look like, and we're going to get straight to it. So the first one we're going to look at is actually the OR statements, because those are typically a little bit easier to tackle. So an OR statement tells us that the values that satisfy or work for either inequality, not both, but one or the other, are acceptable. These inequalities have 2 different lines when graphed, one for each inequality. So if we take a look at this example here, there's an OR statement in this inequality. So I have x is greater than or equal to negative 4, or x is less than or equal to negative 8. So we have two inequalities with the word or in between. Now, two things. Thing number one, there is a boo-boo in the graph. But we're going to fix it right now, and that boo-boo is that this circle should be filled in. It should be a closed circle because both of my inequalities have an or equal to portion at the bottom. So please, please, please fix that. That'd be wonderful. Thank you. It is my mistake. Now, when I'm taking a look at these, when I graph it on a number line, I am simply graphing each one individually. So this is my x is greater than or equal to negative 4. And this is my x is less than or equal to negative 8. In an or situation, I will always have the arrows pointing away from each other. And the reason being is in this or situation, I can have a possible answer like negative 10. Negative 10 is a number that's either greater than or equal to negative 4 or is less than or equal to negative 8. But my numbers that I get as possible solutions will not satisfy for both inequalities. It'll just satisfy one of the two of them. So in or situations, I will always have the graph of my inequalities pointing in opposite directions, not going towards each other, but going apart from each other like we have here. Now, the nice thing is if I wanted to graph them, I would simply graph each inequality one at a time. And if I wanted to write the inequality from a graph, I would just simply write the inequality one at a time and then slap the word or right in the middle. So nothing too crazy, nothing too complex. We just have two inequalities on the same exact number line. And we use the word or in between. Now, the other type of compound inequality is an and statement. So an and statement tells us that values must satisfy or work for both inequalities. It's not one or the other, it's both. Typically, these inequalities represent values between two numbers. So I'm not looking for two inequalities that go in opposite directions. I'm looking for inequalities that go towards each other. So I could look for answers that are between those two given endpoints. When we take a look at these and situations, we could have them in two separate chunks with the word and in between. But more often than not, they are written as one complex inequality that looks like this. Now, the nice thing about that complex inequality is there's a really easy pattern on how we can go ahead and represent it or write it. And here are the steps to write a complex inequality. Step 1, we're going to write the smallest value first, the variable we're using in the middle, and the largest value last. So if I'm taking a look at what I've got down here and I'm trying to turn it into a complex inequality, the smallest value goes first, the variable goes in the middle, and the largest value goes last. That's step 1. So what I'm going to do, negative 2, x, and 1. That's what it's going to look like. And I'm leaving gaps in between because I need to put my inequalities there. Now, the beautiful thing about writing a complex inequality is if we put it from smallest to variable to largest value last, we will actually always use less than symbols because we are setting it up in a way where the left-hand side will always be less than the right-hand side. Right? Negative 2 is always going to be smaller than negative 1, or the smallest will always be smaller than the largest. So we're always going to use less than symbols every single time, provided we set it up this way. The last thing we have to do is we have to decide if we have a filled in circle or a or equal to portion, or if we do not have an or equal to portion. And I'm noticing here, Miss T ended up making a mistake in her answers as well. Because if I'm taking a look, I have the or equal to portion with the 1. So I have a filled circle, so or equal to portion, which means the mistake that I made is this. Please add this or equal to into your notes. This side does not have an or equal to portion, so there is no line at the bottom of that inequality, and this is what I end up with. So I can use these 3 steps to create a complex inequality. Now, that was just a lot of information at once. So compound inequalities, just to recap, they're when I combine 2 inequalities together. They can be combined in an or situation where I'm okay with one inequality working or another inequality working, but not both at the same time. And then there's and statements. And and statements means I want both inequalities, the answers that I'm interested in, to both be satisfied at the same exact time. Now, we are going to talk about some key words before we jump into the practice of the graphing things on the next page. But when I take a look at or statements, I'm really going to see the or show up. Right? And that's totally cool. We'll pretty much have an or going on every single time. And the language that we use on the left and the right can vary. And it could say like less than 7 or exceeds 15. We could say a maximum of 8 or a minimum of 27. Like the language we use on the left and the right that I've highlighted in yellow here can change to match our previous table from our previous set of notes. But the key thing here is for a compound inequality, I will see the word or in between if we're talking about an or statement. If I'm taking a look at an and statement, there's other language that I could use other than and. Sometimes I'll see between. So I'm looking for a number between 8 and 73. Okay. I might say and that can work. I also might say but, right? I want something bigger than 10 but smaller than 15. It implies the same information. There's a few more words that we can use. But again, on the left and the right here, this less than, more than, at most, at least, that language can change to exceeds, does not exceed, a maximum, a minimum, at least, at most, etc. But the keywords that I'm looking for a compound inequality that have an and type setup would be and, between, and but. Okay. We are going to graph some compound inequalities. Now, let's take a look at the first one. Just like our last set of inequalities that we graphed, we started by drawing a number line. And I am going to draw a number line. When we draw this number line, we need to have the 2 endpoints on there, and they have to be in order. So like 7 and 9 are my 2 endpoints. I could see that in my question. I have to put 7 on the left, and I have to put 9 on the right. Because in a number line, the smallest numbers are on the left, and the biggest numbers are on the right. So I need to maintain that order. I'm welcome to add additional numbers in here. I am actually not expecting you to have to put additional numbers on here. So if you wanted to, you can go ahead and put other numbers as long as they're spaced evenly apart. But you do not have to. I am okay with you just having those 2 endpoints for a compound inequality. In my and situation here, I'm actually expecting to have my 2 endpoints and my graph for each one go towards the other. Because in an or situation, I'm expecting the two inequality arrows to go away from each other. In an and situation, I'm expecting them to go towards each other. And so we'll notice that in this graph here. But I'm going to start by drawing the endpoint. So on the 7 here, I will have a closed circle because I have an or equal to portion. For the directionality, since this is written in standard form, I'm looking at my arrow going towards the right. For my next inequality, x is less than 9, I have an open circle because I have no or equal to portion at the bottom. And since it's in standard form, I'm expecting my arrow to go to the left. Now here's the catch. I need my number that I am choosing to be bigger than or equal to 7 and smaller than 9. So what I'm going to do is when these two are facing each other, I'm going to connect those endpoints together, and I'm actually going to get rid of the arrows. And the reason I'm going to get rid of the arrows is if I had an arrow going this way, it would imply it goes this way forever. And when I get to the number 5, 5 is less than 9, but it is not also greater than or equal to 7. So for those reasons, I can't have an arrow. I am only connecting those two endpoints together because I'm only interested in the numbers that are both greater than or equal to 7 and less than 9. So possibilities could be 7, 7.3, 7.8521631, could be 8, could be 8.999994. It can't be 9, but it could be any of those numbers in between 7 and 9, not including 9. So that's what my graph is going to look like. Okay, the next one, B, I have an or situation. I can tell it's an or situation because it says the word or in between. And just like before, I'm going to have my two endpoints, negative 21 and 15. The smallest one written on the left, the biggest one written on the right. Now, before I even start here, I know what an or situation looks like. It looks like the two arrows facing away from each other, apart from each other, but I can confirm that in what I'm about to do. So I'm going to graph this one first. I have x is less than negative 21, so I will have an open circle. There's no or equal to portion to it. And my arrow will be facing the left direction. So I'm looking at numbers less than negative 21. Or if I'm matching that standard form here, I know it's going to have the arrow pointing the same direction as my inequality. For this next inequality, x is greater than 15. I'm also going to have an open circle here because I have no or equal to portion. And that arrow is going to be pointing to the right because numbers bigger than 15 could be 16, 17, 18, 19, etc. In an or situation, I was actually anticipating for these arrows to go in opposite directions. So luckily for me, my answer did match what I was expecting. So and situations, my numbers or my number lines will go towards each other. Or situations, my number lines will go apart from each other or away from each other. Okay, the next one is an and situation, but it's written as a complex inequality, which means we have two kind of possibilities of doing this here. Possibility number one is we can start by drawing our endpoints, 5 and 8. And we can draw the inequalities, I could draw my circles based on the inequalities. On the 5, I will have an open circle because there's no or equal to portion here. On the 8, I will have a closed circle because there is an or equal to portion here. And in an and situation, I know my inequality direction of my graph will go towards each other, so I can connect them this way. Now that's probably the fastest way to do things. But if you're like, whoa, how did you know that? I am going to show you how we can also do this in 2 steps. So you'll notice I kind of broke this inequality up. I said 5 is less than x, and I also have x is less than or equal to 8. Now the second guy, it's in standard form. I'm really happy about it. Life is pretty good. This first guy is not in standard form, so I'm going to change the direction of the inequality and flop the orders. I could now tackle this as 2 inequalities separately and graph them. So here I have my open circle at 5, my arrow going to the right. Here I have my closed circle at 8, my arrow going to the left. And I will notice that I end up with the same answer. I'm going to connect those 2 endpoints together. Okay. The last one is another OR situation. Can you pause the video and try this next one on your own? Okay, welcome back. I have this here. So I have x is greater than 32 or 4 is greater than x. I am starting by putting my 2 numbers on here. I have to put 4 on the left and 32 on the right because number lines always go from smallest on the left to biggest on the right. Now, as I'm graphing these, I notice that this inequality, the second one, is actually not written in standard form. I like graphing things from standard form. So I am going to flip the directionality here. So I have x is less than 4. You could, of course, keep on graphing from this non-standard form. I personally have that preference. So I am going to graph each of them individually. So this first one here, x is greater than or equal to 32, closed circle. Arrow goes towards the right, to where the bigger numbers are. For the second inequality, I'm going to graph it from standard form, but either way, I'll get the same answer. I have an open circle on 4, and my arrow pointing to the left. And again, in OR situations, I'm expecting my arrows to go away from each other. Okay. Man, that's been a lot so far. But you know what? Let's keep going. We are now going to do the same thing backwards. We are going to take a look at the graphs, and then we are going to go ahead and write the inequalities. Before we get started, can you pause the video, turn to someone next to you, and tell them which situations you think are OR situations, and which situations do you think are going to be AND situations? Go. Lovely. So, for the first one, I'm going to have an AND situation because I see my inequalities, my 2 endpoints are connected together. And that is more than totally fine. In my next one, I have an OR situation because I can see my inequality, my arrows are going apart from each other, not towards, they're going away. The next one, OR. The next one, and, OR. Okay. Now I'm going to tackle these a little bit out of order. And I'm going to start by doing all of the OR situations first. I find the OR situations easiest because I can simply go ahead and do each inequality separately and slap the word OR in between. So I'm going to do one. You're going to pause the video. You're going to do the last 2. So for this first one here, this one on the top right, this inequality, I'm going to pick a variable, any variable I want. And I have x that I've chosen. I have the number 2 because that's where my endpoint is. And that's all great and dandy. I'm going to put the directionality of my inequality. Because I'm writing this in standard form, my directionality should match my arrowhead. But also I know the numbers -2, -1, 0, 1. They're all less than 2. And last but not least, I have to decide if I'm going to have an OR equal to portion involved. And I will, Because I have a closed circle. Then I'm going to tackle my next inequality. My next inequality, I have to use the same variable for. So if I chose x here, I have to choose x there. If I chose a, I have to use a again. If I used q, I have to use q again. Because if I'm talking about the same number line, I have to be talking about the same variable. Okay? So we can choose any letter we want. We just have to be consistent or use the same variable for the whole entire question. Okay, I know the number involved in that inequality will be 7 because that's where my endpoint is. I know my directionality of that inequality will match my arrowhead when written in standard form, but also 8, 9, and 10 are all bigger than 7. And then I will have an or equal to portion because I have a closed circle. That's actually it. Oops. Let's try fixing this here. I want to get rid of the highlighting. But that's it. This is my final answer. Because in an or situation, I do not have to put them together. I simply go ahead and write both inequalities, and I use the word or in between. Now, what I'd like you to do is I'd like you to try the next 2 or situations. Pause the video, give them a go, and then come right back. Okay, I'm going to go through these, and we go through them a little bit quicker, but we're going to do them together. Taking a look at this guy, I'm going to look at this inequality first, and I'm going to use the variable y. I have my endpoint at 3. I know I have less than 3 because all those numbers where my arrow is located are less than 3, but I'm also matching the directionality of my arrowhead. And I have no or equal to portion because I have an open circle. And then I have this or that I'm writing in between because in an or situation, I write 2 separate inequalities and write the word or in between. And then I do the same thing for the second inequality. I'm keeping my variable, so I chose y before, I have to choose y again. My endpoint is 5. I will need to have a greater than symbol and no or equal to portion because I have an open circle. So this is what I got. The last one. I am going to choose the letter, I don't know, T. I have T. I have -5. I have a less than symbol in between. I have T. I have a +1. I have a greater than symbol in between. And because it's a closed circle, I need that or equal to at the bottom. And of course, I need to combine those 2 single inequalities with the word or in between. Okay, hopefully, or situations and writing those inequalities are feeling pretty good to us. Nothing too crazy, nothing too kooky, nothing too wild. Let's talk about and situations. So the remaining 3 here are all going to be and situations. And I know that because of how the graph looks, in the sense that my 2 endpoints are connected with a line. We don't have 2 arrows going away from each other. We have those 2 going towards each other. Now, when we represent an and situation, we must do it as a complex inequality if we want all the full marks. If we wrote them as 2 separate and wrote and in between, you technically get a communication error because it's not the best way to represent it. So we are going to write these as complex inequalities. We're going to go through that process together. So if we remember the steps on the previous page, great. If we don't, that's okay because I'm going to walk you through them anyways. So for this and situation, I am going to start by writing the smallest number of my endpoint first, the variable that I choose in the middle, and the largest value of my endpoint last. So here I've written 7, I left a space, x, left a space, and 8. Next, so that's step 1. Step 2 is I'm going to throw, less than symbols in between each of these. And it's actually always going to be less than symbols because I am intentionally writing it in the order where I have my smallest value first, the 7, my largest value last, the 8, and the value of my number has to be between 7 and 8, so that's going in the middle. If I wrote it with the 8, then the X, then the 7, my strategy doesn't work so much. So we're setting it up intentionally to make sure that less than symbols can be used. Last but not least, I am deciding if I need to add or equal to portions at the bottom of those inequality signs. For the 7, I do need to have one because I have a closed circle on the 7. And on the 8, I do need to have one because I have a closed circle on the 8. And this would be my final product. I'm going to do one more with you for the and situation. I'll get you to try the last one on your own. We're going to do this next one here. So I'm going to start by using my smallest number of my endpoint. It's not explicitly labeled, but I know it's between -6 and -8, which means it must be -7 here. I'm going to use the variable that I plan on using in the middle. I'm going to use y this time. And I'm going to use the value of my endpoint furthest to the right, my biggest endpoint, which is 6. And then I'm going to put less than symbols in between both of my variable and numbers. And then last but not least, I'm going to decide if I need the or equal to portion at the bottom or not. For the -7, I do need one because it is a closed circle. For the +6, I do not need one because it's an open circle. And this is my final answer. Can you please try this last one on your own? Pause the video, give it a go. Okay, welcome back. So, smallest value first. Variable in the middle. I'm going to use t. Biggest number of the endpoint last. Less than symbols in between. No or equal to for the -4 because it's an open circle. There will be an or equal to with the +3 because it is a closed circle. And that there is my final answer. Now, if you've been thinking to yourself, man, we did so much good graphing today. I wish there were word problems. We got you. Don't even worry. So we are going to take a look at this last example. And in this last example, we are combining a couple of skills. Skill 1 is we are going to make sure we define variables, right? Our variables need to be numeric and specific when they're defined. We could always look at units to help us kind of figure out what that variable must be. And then step 2 is we're going to write an inequality. In this case, they're all going to be compound inequalities that represent the situations below. So if I see something like or, I'm going to write 2 separate inequalities with the word or in between. If I see something that says and or but or between, I'm going to make sure I'm going to do that big complex inequality. Okay, so taking a look at the first one. Cookies need to be baked for at least 10 minutes and no more than 12 minutes. So as I was going through, I read the word and I'm like, oh yes, this is an and compound inequality. I'm looking at my units and I'm like, hey, look, everything's measured in minutes. What's measured in minutes? Oh, I'm so glad you yelled it all out at the screen. I'm going to let T represent time. The time baked in minutes. All right, and again, I'm being specific because what is that time for? Well, it's the time the cookies are baking in the oven. And what are they measured in? They're measured in minutes. So I'm numeric and I'm specific. Now, I have an and situation. And an and situation, we write that complex inequality. Remember, when I'm writing that complex inequality, the smallest endpoint will come first. And the smallest number is 10. My variable, which we've defined as t, will go in the middle. And the biggest endpoint, which is 12, will go last. I will for sure have less than symbols in between because I've intentionally set it up so that my left-hand number, it will always be smaller than my right-hand number. Then I have to decide if I have the or equal to portions involved. Now, if I'm looking at this, it says at least 10. Is 10 included in at least 10? Yeah, because at least means 10 or more. So I'm going to have the or equal to portion with the 10. For the 12, it says no more than 12. So no more than can also mean 12 because 12 is not more than 12. So it will also have the or equal to portion here. And that is my complex inequality. That's all I'm going to do with it. I'm going to write it out. I'm going to call her a day. The next one. You must practice your instrument more than 20 minutes a day and less than 90 minutes to meet your music teacher's expectations. Cool. I have another and situation I could tell because the word and was used. And I'm going to go ahead and do the same thing. I'm looking for my units to help me define my variables. My units are in minutes. What is measured in minutes? Well, of course, it's time. I'm going to let T represent the time spent practicing. In minutes. And just like the one above, I have an and situation. So I'm going to write the smallest number, the smallest endpoint first. My variable, and again, we define the variable as T in the middle. And the largest endpoint last. So I have 20 space T space 90. Next, I'm going to put less than symbols in between. And they're always going to be less than symbols if I set it up with the smallest number first and the largest number last. And then I'm going to take a look at my language. It says more than 20. More than 20 does not include 20. So I'm not going to have an or equal to portion on the inequality with the 20 involved. And then I see I have less than 90. 90 is not included if I need to be less than 90. So I'm also not going to have an or equal to portion with the inequality that involves the 90. So this here is my inequality. Okay, last one. In the last one here, you want to take a nap that is less than 20 minutes or more than 90 minutes. Right? You can do a really short nap and then get things done, or you could do a long nap and be like, you know what, that's it. But you don't want to nap for any time in between. So it's either going to be less than 20 or more than 90 minutes. And again, I'm using my units to help me define my variable. Once again, we've got time, but this time we're still going to use T. So let T represent the time spent napping in minutes. Okay, in or situations, we are tackling each inequality completely separate, and we're writing the word or in between. So I'm going to write an inequality that says less than 20 minutes. So the time T spent napping is less than 20 minutes. And the other inequality is the time spent napping is more than 90 minutes. So T is greater than 90. In an or situation, we simply write the two separate inequalities and again use the word or in between. If I used a T to define my variable, I need to involve T's in the inequality. If I used X, I have to use X's. If I defined it as an M, I need to use M's. I just need to be consistent with that variable usage. Okay, that was a long lesson, I'm telling you. But we are done, and there's some practice that follows. So if you can take a look and start tackling that practice, that would be the dream. I hope you have a really great day, and I hope you learned something new. Bye.